There are different ways of presenting similar triangles. Like the example that I've shown you, there are three different ways of showing two similar triangles. Okay, the first one is triangle PAB being embedded in a bigger triangle PQR. And then the second type, you can see that the two triangles that's being connected at point C, and then the third type also being connected at point R. Right, so for the second and the third type of similar triangles, it may be a little bit difficult to visualize where the corresponding angles are. So I'm going to use second type of triangles to show you how we can split the triangle into two similar triangles, a big one and a small one, and from there we can try to visualize where the corresponding angles are. Okay, so but before we do that, I think it's good that we identify where where are the angles that are the same. Like in this case here, angle ABC is equals to angle EDC, AB being parallel to DE, so we can use alternate angle properties. And then I color the angle yellow, and then angle BAC is equals to angle DEC. I use the double arc to represent it. Then angle ACB is equals to angle ECD. I used green arc to represent them. Okay, so after you have done this groundwork, we can split it into two similar triangles. Two triangles of the same shape but different size. Okay, and then you fill in the informations that we have done earlier on. Right, so from these two diagrams, some of you may be wondering why is A, B, C and equals to EDC, why are they called corresponding angles? And also why is BAC equals to DEC being corresponding to each other? Okay, so the next diagram I'm going to show you is I'm going to overlap these two triangles. Right, so when overlap them, then AB being parallel to ED, so you can see from the diagram that CAB corresponds to CED. That's why they're called corresponding angles. Right, the second diagram you may not be able to visualize why are they corresponding angles, but once you put these small and the big triangles, you put them in the overlap position, then you can clearly see that CAB corresponds to CED, CBA corresponds to CDE, then the sides BC corresponds to DC, AB corresponds to ED, AC corresponds to EC. Another way of overlapping them would be this type of arrangement, and then from there you can see that angle ACB corresponds to angle ECD. Right, when you're doing such questions, there's no need to show the last two diagrams. Okay, you just have to show you just have to split the big diagram into two similar triangle, a small one and a big one, fill in all the informations, and then you'll be able to find the corresponding sides and the corresponding angles. Right, so once you have learned this skill, you can go about solving any kind of a similar triangle. So I'm going to show you another example. Okay, right, so using the same skill we've learned just now, we split it into two similar triangles, a big one and a small one. Right, fill in the information, and then you can write the statement. So from there we can see that angle DAC is equals to angle BAE because they are common angles, and then angle ADC equals to angle ABE equals to 90 degrees because it's given in the diagram. So therefore both triangles are similar using AA similarity test. Then from there we can also see that AD corresponds to AB, DC corresponds to BE, and AC corresponds to AE. And angle DAC corresponds to angle BAE, angles ADC corresponds to angle ABE, and the last pair is angle ACD corresponds to angle AEB. Right, so I hope this simple PowerPoint slides will help you to understand this chapter better.